Hello dear students, my name is Mujamangu Diogene. I am a teacher of physics. Today's topic is quantitative analysis of linear motion. Goals of this lesson are to describe and define linear motion. The second one is to define terms like distance, displacement, speed, instantaneous speed, average speed, velocity, and acceleration. Without delaying, let's move on. Here there is a picture. If you observe clearly this picture, you will see that here we have a car. Car is here. It is moving. The car is moving along a straight line, which means that linear motion is a motion which is done along a straight line. But before talking too much about linear motion, let's have an overview on mechanics. As you know, mechanics is one among branches of physics. It studies the motion of objects and the related concepts of force and energy. In general, that is mechanics. Mechanics also itself has three branches. The first branch is statics. Statics is the study of bodies in equilibrium, or bodies at rest, or bodies which are stationary. Other parts are kinematics. Kinematics deals with bodies which are moving but without considering the cause of the motion. So we don't consider what made the body to be in motion. The last one is dynamics, which deals with force and why objects move as they do. In dynamics, we include the term force, and also we consider the reason behind the motion of the body, which is different from kinematics. In general, those are the three parts of mechanics. As you know, we have other branches of physics which are not mechanics. For example, we have thermodynamics, we have nuclear physics, and so on. Let's continue with our concern, linear motion. Linear motion, as I have said it above, it is the motion in a straight line. We can also call it rectilinear motion. This part also has two types. We have uniform motion and non-uniform motion. In uniform motion, the speed is constant. It is the body which is moving with a constant speed. If I take an example for bodies which are moving, let's take example of a body which is moving from A to B. A body which is moving from A to B. Take like this motion of a body which is moving from A to B. Now, let's say that the body started here with 20 meters per second at point A, and it has reached here at point B also with the same speed, 20 meters per second. 20 meters per second. You can say that this body is moving with the uniform speed. So it is a uniform motion. This is a uniform motion. because the speed is not changing. Okay, now let's see another type also of linear motion, which is non-uniform motion. In this motion, the speed of an object changes at a constant rate. A good example is a free fall. Here the speed is changing. Okay, the speed is changing, but the way the speed is changing is uniform. We have taken an example of free fall. For free fall, if it is when the body is falling freely. As we know, in a free fall motion, you know that acceleration due to gravity, which is g, is equal to 9. It is equal to 9.8 meter per second. 9.8 meter per second squared. It means in each second, when a body is falling, in each second the speed is increasing by 9.8 meter per second. It means that each second, you know, here there is 8 meter per second. The speed which is being increased each second, there is a constant increase of speed. That is non-uniform motion, which is different from uniform motion, where in uniform motion the speed is constant. It is not increasing, it is not decreasing. But in an uniform, the speed is changing uniformly. Okay, we can move on the distance. I hope that you have understood the difference between uniform and non-uniform motion, which are types of linear motion. Okay, we move on to distance. Distance is the total length of the path followed by an object, regardless of the direction of motion. Total length followed by an object, regardless of the direction. This is very important, this term, regardless of the direction of motion. Okay, so we don't consider the direction of the motion. I think we can take an example of a body which is moving from A to B. From A to B, for example, it is from A to B, we have 20 meters. So if a body moves from A to B, the distance it will move will be the same as the distance if the body moves from B to A. If we have two bodies, one body moves from A to B, another body moves from B to A, so they will move the same distance. Okay, also if one body moves from A to B and returns back to from A to B and returns back from B to A, the distance will be 40 meters. Okay, I repeat, if one body moves from A to B and returns back to A, the total distance will be 40 meters. If from A to B there is 20 meters. Okay, so you consider the whole path a body has traveled. Okay, what I can also say is that it is a scalar quantity and it is measured in meters as SI unit. Okay, I hope that you remember a scalar quantity. A scalar quantity is any quantity which has only magnitude or size. It doesn't matter about the direction. In a scalar quantity, we don't consider the direction of the body. Okay? Another example of scalar quantity is volume, time, density, and so on. All of those are scalar quantity. It doesn't matter which direction the body is moving. Okay? Let's continue. Here on displacement. If you have understood where the distance, now you have to pay attention about the displacement. Displacement is the object's overall change in position from the starting to the ending point. Okay, from the starting to the ending point. It means here also we can define it as the shortest distance along a straight line between 2 points in the direction of motion. For here, direction is very, very, very important. Okay, direction, in the direction of motion. Okay, here we consider the direction. That's why distance and displacement are not the same. Okay, the units, SI units, are the same, but there is a slight difference, because for distance we don't consider the direction, but for displacement direction is very important. Okay, here there is here there is a diagram which is showing you the difference between the distance and the displacement. Here there is I don't know if it is a person, or let's say it is a body, it is a car or another body which is moving along this road. As you can see here, there is a road which is not straight. This road is somehow zigzag, it is not straight. Okay, so a body moves from A to B. Then if someone asks you to find the distance, now you consider the length of the road. Here the length of the road is 142 kilometers. The distance will be 100 distance. Here, as you can see, distance will be 142 kilometers. While displacement will be the shortest distance between A and B. It is the shortcut from A to B with this direction. It is 100 kilometers. It means that I don't consider the whole path. No, I only consider the shortcut. I draw a straight line from A to B with the arrow to show the direction. This will be the displacement. So if you show this straight line without this arrow, it is not correct 100%. You must show the arrow. If you don't show the arrow, someone may say that it is from B to A, which is not the same as from A to B. Okay, when it comes to displacement, you have to indicate the arrow. If you don't indicate the arrow, the answer is not full. Okay, so I hope that you have understood the distance between, the difference between distance and displacement. Displacement is a vector quantity. A vector quantity is any quantity with both magnitude and direction. Another example for vector quantity is a force. Vector quantities are defined by both magnitude and direction. If you say magnitude only, the answer is not 100% correct. If you indicate only direction without magnitude, also it is not okay. It goes with both magnitude and direction. I hope that you have understood the difference between distance and displacement. Let's continue with the speed. What is the speed? The speed is the distance moved by a body per unit time. Its SI unit is meter per second. Now, when a body covers equal distance in equal time intervals, it is said to move with uniform speed. Now, speed, you can write this V to show speed. It is the distance over time. It is the distance over time. Unit is meter per second. That is the speed. It is also a scalar quantity. We don't consider the direction. Now, let us see what we call instantaneous speed. It is the speed at any given instant in your journey. For example, when a policeman take the speed of the car which is moving using speedometer, that speed is instant speed. Because if I take an example of a car which is moving from Kigali to Huye, now it continues changing the speed at different times. But if I take one speed of that car, that is, I can call it instantaneous speed. The speed at a given time, a speed at a given instant, it is called the instantaneous speed. Now, average speed of a body is the total distance covered by the body over total time taken. For example, a car moves from Kigali to Huye. From Kigali to Huye, let's assume that there are 100 kilometers. That is assumption, 100 kilometers. Now, the time from Kigali to Huye, let's say that 3 hours. 3 hours from Kigali to Huye. Now, the average speed will be the total distance. That is 100 kilometers. I divide by 3 hours. Now I can consider, now I may say that the average speed will be that 100 kilometers divided by 3 hours. Okay, that is the average speed. Now let's continue about velocity. Velocity is the displacement covered per unit time, or the rate of change of displacement. Now, because the velocity is a vector quantity, to define it, to use a displacement, because displacement also is a vector quantity. So you take a displacement, you divide by the time. So SI unit also is the meter per second. When velocity in a particular direction is constant, velocity is referred to as a uniform velocity. It means that a constant velocity. Okay, now we have understood the difference between speed and velocity. Speed is a scalar quantity, while velocity is a vector quantity. Speed is the distance moved by body per unit time, while the velocity is the displacement covered per unit time. So this one is asked many times to differentiate between distance and between speed and velocity. They also ask many times to differentiate between distance and displacement. I hope that now you are able to differentiate them. Okay. Let's continue with the acceleration. Acceleration is defined as the rate of change of velocity. Now you can see that we have used the term velocity. So it means that acceleration also is a vector quantity. Okay? It is a vector quantity. It has also a direction. So when you accelerate following a given direction. Okay? So that's why acceleration also is very, when you define acceleration, it is very important also to know the direction. Okay? The SI unit of acceleration is meter per second squared. You have to note that acceleration due to gravity is equal to 9.8 meter per second squared, as I have stated it above. We cannot say acceleration without also saying about deceleration or retardation, which is a negative acceleration. Negative acceleration means that a body now is reducing the speed. Okay, a body may move from the speed of 80 meter per second, then 80 meter per second up to 40 meter per second. 40 meter per second. It means that now the body has reduced the speed. That is deceleration. The body has decelerated. Okay. When the rate of change of velocity with time is constant, the acceleration is referred to as a uniform acceleration. So that is what we can talk about this quantitative linear motion. So next time we shall take another point, because it is a very big topic that we shall be discussing step by step. Now, as a homework, there are questions that I can give you as homework. Question 1, it is to differentiate between speed and velocity. Okay, differentiate between speed and velocity. That is 1. Question 2, you have to differentiate between distance and displacement. Okay, question 1, differentiate between speed and velocity. Question 2, differentiate between distance and displacement. Thank you so much for paying attention. We shall meet next time.